Okay, so we're doing 7.2 exponent laws, which is sort of a continuation of yesterday. So using the exponent laws, we can learn two more rules. And I talked about them at the end of yesterday's notes. So when we look at them, we have negative rule, which is if I give you 8 to the 3 over 8 to the 4, we know from yesterday because we're dividing, we'll end up subtracting the exponents. So when we subtract them, we get 8 to the negative 1. Now if you were to write this as repeated multiplication, you had 3a's over 4a's, so 3 of the a's would cancel out and you would be left with 1a in the denominator. So a to the negative 1 is the same as writing 1 over a. The other rule that we have is zeros. If I give you a to the 3 over a to the 3, from yesterday dividing, we know that we subtract them, 3 minus 3. But what's 3 minus 3? It's a to the 0. Again, if we write it as repeated multiplication, everything cancels out and we're left with 1. So as I said yesterday, remember a to the 0 is stating that the base appears 0 times. But if we look at this, we see that the imaginary number in front, the coefficient, is a 1. So we hold the place with the coefficient of 1, but none of the bases. On this side, remember I gave you the example of writing it with numbers. So you could, again, you could do it with, let's say, 3 to the 3rd divided by 3 to the 4th. You would get 3 to the negative 1. But if you write it as 3 times 3 times 3 over 3 times 3 times 3 times 3, you would get 1 over 3. Okay, so 1 over 3 would be the same as 3 to the negative 1. All right, so key rules. A base to a negative power means flip the base and write it with a positive power. And any base to the power of 0 is always equal to 1. Okay, so any base to the power of 0 is equal to 1 because your base did not appear. So let's look at these examples. All right, so 2 to the 0 is 1. Negative 5 to the 0 is 1. 0.4 to the 0 is 1. 2 to the negative 1 tells you flip your base. So remember, 2 as a fraction is 2 over 1, so we flip it and we get 1 over 2. We now write it to the positive 1. We get 1/2. Negative 3 to the negative 2. We're going to flip negative 3, so we get negative 1 over 3, because you always want to write the negative sign in the numerator on top. And now it's to the positive 2. So we get negative 1 is going to be squared, and the bottom is going to be squared. 3 is going to be squared. So negative 1 times negative 1 is positive 1. 3 squared is 9. So let's look at the next question. So we had negative 3 to the negative 2, and now we have 3 to the negative 2. So 3 flips, it becomes 1 over 3, and it's to the positive 2. So 1 squared over 3 squared is 1 over 9. So we get the same answer. Okay, so notice the sign between your bases flipping does not change. Only the exponent changes when you flip. Negative 4 squared, okay, it's not a negative exponent, so you don't flip. You just say negative 4 times negative 4 and you get 16. So now I want you to try these questions, the second line of the examples, and then come back. So pause this for a couple minutes and then come back. Alright, so now we can see negative 4 to the negative 2. Your base is only the 4. So the base of 4 flips to 1 over 4. So 1/4 squared will be 1 squared over 4 squared, so we get a negative 1/16. Okay? The next question, what's your base? And flip it. So your base was negative 1 over 2. We flip it, it's negative 2 over 1 to the positive 3. So negative 2 cubed is negative 2 times negative 2 times negative 2, which gives you a negative 8 over 1, and you don't have to put the over 1. Okay, 2/3 to the negative 1. What's your base? The negative tells you to flip it. So you get 3 over 2, which is to the first power now, and we just get 3 over 2. 2/5 to the negative 3 flips to 5 over 2 to the positive 3, so 5 cubed over 2 cubed. 5 times 5 times 5 is 125. 2 times 2 times 2 is 8. So just leave it as an improper fraction. Okay, so 125 over 8. Now if I have this on a test and you write the answer as a decimal, all I know is you know how to use your calculator. You're not proving to me that you know what a negative exponent means. So always leave your answers in fraction form and improper form. All right, so now 3x to the fourth to the negative 2. What's your base? So it's this entire thing is going to flip to go in the denominator. So 1 over 3x to the fourth to the positive 2. So we square the top, square the bottom. Squaring the bottom, 3 times 3 is 3 squared, so 9, and then power to a power, so 4 times 2 and x to the 8. All right, m cubed over 2 to the negative 3 is going to flip to the positive 3, so 2 cubed over power to a power, so 8 over m to the 9. And then this last one before we get to the next example, to the negative 3 tells you flip. Okay, so we flip it. We do power to a power. So negative 2 times 3 and x to the third. So we get x to the negative 6 over x cubed. Because this is a negative, it flips and goes to the bottom. Notice x to the 3 did not have a negative exponent, so that does not move. Okay, so this would be the most complicated that you would see. So just pay attention that only the base that has the negative exponent flips. All right, example 2. Use the exponent rules to express each of the following as a single positive power, then evaluate and leave in a fraction. All right, so I want you to pause the video, use your exponent laws, and then come back. All right. So, coming back now, we see that we have multiplication, so we add the exponents. So 4 plus negative 3 is going to end up giving you 3 to the 1, which is just 3. Next, same base, multiplication, so we add the exponents. So negative 2 plus negative 3 gives you negative 5. 4 to the negative 5. We'll flip the 4 to be 1 over 4 to the positive 5, and then 1 to the 5th over 4 to the 5th gives you 1 over 1024. Okay, next question. Negative 5 to the negative 3 times negative 5 to the 5, adding your exponents again, so negative 5 squared, and then evaluating negative 5 times negative 5 gives you a positive 25. And the last one on the first row, 2/3 multiplication again, adding the exponents, so we get to the negative 5th, flip to the 5th, so 3 to the 5th over 2 to the 5th, so 243 over 32. All right, so now we have a few more examples. Try these again, pause the video, and then come back when you're ready. All right. So now we can see that we are dividing, so we're subtracting the exponents. So negative 9 minus negative 7 is going to become negative 9 plus 7. So 4 to the negative 2, flip your base, and raise it to the positive power. So 1/4 squared evaluates to 1/16. Next question. 3, you're going to subtract your exponents, so we get 3 to the negative 7. Flip your base, 1/3 to the 7 would be the way that you would simplify it and leave your answer in simplified form, and then evaluating 1 to the 7th over 3 to the 7th is 1 over 2187. Power to a power, you multiply the exponents, so negative 2 times 4 is negative 8. Flip your base, so 1/3 to the 8th would be the simplified answer, and then 1 to the 8th over 3 to the 8th gives you 1 over 6561. Again, 4 squared to the negative 2, multiply your exponents, so 4 to the negative 4. So flip your base, 1/4 to the 4th would be your simplified answer. Evaluated, 1 to the 4th over 4 to the 4th gives you 1 over 256. And the final question, 2 to the negative 2 raised to the negative 3. Multiply your exponents, so 2 to the 6th. The negative canceled out, and you're just left with 2 to the 6th power, which is 64. Okay, so now I want you to work on the homework sheet. The answers are included.